Hello grade 10s and welcome back to another theory video. In this video we will be taking a look at resistance. We say that resistance is the ratio of potential difference across a resistor to the current in the resistor. Now the use of words here is very important. We measure potential difference using a voltmeter. And as you can see in this rough sketch, the voltmeter is connected in parallel. This is very important. We therefore use the word across when referring to the potential difference. We say that we measure the potential difference across a device. On the other hand, when it comes to current, we measure current with an ammeter. And as you can clearly see, an ammeter is connected in series to the resistor. Therefore, we measure current in the resistor, or we could say the current through the resistor. In symbol form, we have R for resistance is equal to V for potential difference divided by I for current. Resistance is measured in ohms, spelled OMS, and it has the symbol omega. Potential difference is measured in volts, as you already know, given the symbol V. And current is measured in amperes, where amperes is given the symbol A. This relationship between potential difference and current is known as Ohm's law, and you will be taking a look at Ohm's law in a lot more detail in grade 11. Basically, what we can gather from this formula is that if we have a resistor whose resistance we do not know, we can connect it to a source of power, allow current to flow through it, and measure the potential difference across it. Then we can divide the potential difference across it with the current through it, and we will be able to obtain its resistance. Now, this definition can be a bit confusing, so let's look at a different definition. This definition says resistance is the opposition to the flow of electric charges. So in other words, when a device or a conductor has resistance, it makes it difficult for electric charges to flow. Now, the reason this happens is because the electrons moving through the conductor collide, which means they bump into the particles of which the conductor is made, and they then transfer kinetic energy. What we are basically saying, grade 10s, is that any conducting wire is made up of particles. We normally call these particles atoms, right? So this conducting wire that I am representing with a square is made up of atoms. Electric flow or electron flow can also be referred to as current, is basically electrons that are trying to move through this conductor to the other side. But based on what you know from the kinetic molecular theory and states of matter, particles are constantly in motion, right? So they have kinetic energy and they are constantly vibrating, and they're vibrating randomly. So what basically happens is that when the electrons, the charged particles, try to move through this conductor, they end up bumping into the atoms. And when they bump into these particles, they lose kinetic energy. They lose energy, and when we refer to resistance, we're in a sense referring to this loss of energy. The more difficult it is for the electrons to flow, the higher the resistance of the conducting wire. Now, there are a few factors that affect the resistance of conductors, and you need to be familiar with these factors. Number one, we have the type of material that the conductor is made of. So different conductors are made up of different materials, and their resistance is actually influenced by what these conductors are made of. So from your periodic table of elements, you will know we have many different metals, such as silver, copper, gold, aluminium, beryllium, etc. We normally use copper metal as conducting wire for our circuits, but it turns out that silver is actually a better conductor than copper wire. Silver, of course, is just more expensive, and we can't find as much of it as we can copper, and that is why we prefer to use copper. Metals like gold, aluminium, beryllium, etc. can also conduct electricity. They're not as good conductors as copper, but even gold, for example, is a very expensive metal. All that you need to know is that the type of material definitely affects how much resistance conductors offer. Then, number 2 on our list is length. We say the longer the conductors are, the more resistance they will offer. So over here we have a cartoon to help us make sense of this. If we look at the top illustration, you will see the first wire is very short. The second one is a lot longer. If we look at the little cartoons, the little electrons, for the short conducting wire, the electron says, so soon, made it, right? So it was very easy for these electrons to flow through this conducting wire. But for the longer conducting wire made of the same material, the electrons are saying, are we there yet? Must go on, it's so difficult, right? Basically implying that the longer the conducting wire is, the more difficult it is for the electrons to flow through, or rather the more energy they're going to lose along the way, because they're going to be colliding with the atoms in the metal of a long conductor a lot more than in those of a short conductor to get from one side to the other. Number 3 on our list is the thickness of the conductor. We say a thinner conductor offers more resistance. That means that if the conductor is thick, it will offer less resistance. So here we have a cartoon as well. As you can see, here's a thin conductor, and this one is a lot thicker. The electrons are moving through the thick conductor with relative ease. As you can see, the one is whistling and the other one is smiling. But if we look at the other one, over here, the thin conducting wire, they're struggling to move through the thin conducting wire. Of course, electrons are not like us, they don't have feelings, but I'm hoping that these cartoons will make it easier for you to remember the relationship between these factors and resistance. Lastly, we have the temperature of the conducting wire. We say the higher the temperature, the more the resistance will increase. So higher temperatures cause an increase in resistance. So you may remember, once again, I know I've referred to this many times, but the kinetic molecular theory, which says that if we are looking at particles, particles have kinetic energy, and temperature is a measure of the average kinetic energy of particles. Particles are constantly moving or vibrating about their fixed positions, and if we heat up the conducting wire, what basically happens is these particles start to move about even more and they vibrate more randomly. Okay, so if they are vibrating more randomly and electrons want to move through this conducting wire, the vibrations make it more difficult for the electrons to move through, or rather we can say that along the way, they're going to bump into the atoms more often and lose a lot more energy. So, in other words, if a conducting wire is cooled down, then the resistance will decrease and it will conduct electricity even better. These are the 4 factors that are going to influence resistance. Make sure that you learn them off by heart. We've reached the end of this video.